All right, so we are live. Hi everyone, good morning if you're in India. If you're in the US, good evening. If you're somewhere else, I'm not aware of a lot of time zones, but thank you so much for joining. It's 6:30 a.m. in the morning here, and I'm really happy that I could stream on time. So yeah. All right. Let me quickly open my chat on my different machines so that I am aware of what's happening. I think I'm live. Yes, and I can see the chat. Yeah. All right, guys, I can see you. I mean, I can see your chat, so that's okay. That's all okay. Um, let's do a 3-column layout. Is it? Yeah, this is fine. So what I'm gonna do is I'm gonna actually go for starting to revisit my blogs on Rust. So whatever notes I had taken, I'm gonna revisit them. Right? That's the whole goal. To try and understand how we can do better, how I can remind myself what I had done before. Right? So that's the first target. So I'm gonna open Firefox here. Right, and I'm gonna open chumali.github.io. So that those are the blocks that I used to write about Rust. Right, and I'm gonna quickly turn on the dark mode just to make sure that everything is good. Give me 1 second, guys. I don't know what's going wrong. Alright, yeah, it seems to be working now. But did the stream end for some reason? Why did it end? Wait, what's going wrong? I don't know. It says that it ended for me, but it has not, right? Is anyone here? That's just me. It looks right to me. I don't know why it's should be right for people, right? What's wrong, Twitch? What are you up to? See, I'm live. That says I'm live. Okay. Yeah, I'm live. I think everything is good now. Cool. Sorry, guys. Sorry for the panic. The panic mode was on, and that's why it happened. All right. So today, what I want to do is I just want to go through all my Rust blogs, right? So I'm gonna go to categories, and Rust, and go through each one of those blocks. Oh, I just have 2 blocks. That is a shame. All right. So let's not do that. Then let's go to the slang book. Uh, Probably let's start with hello world. Just try to revise what was there so that we just to make sure that I have not forgotten any of those things. Let me quickly change the layout as well. I think I'm gonna prefer spiral layout. Yeah, that looks better for me. Now zoom in for this. So yeah, there you go. All right, so what does it say? Creating a project directory, rust c main.rs. That's gonna compile the file. ./main. That's gonna run it. So it's gonna convert it into a binary. That looks right to me. That's okay. Function main, println macro. That is okay. Rust c file name, and you can do ls. You can see ./main. All right, so that is good. Let's go to hello cargo. Cargo is Rust build system and package manager. Most Rust stations use this tool to manage the Rust projects because cargo handles a lot of tasks for you, such as building your code, downloading the libraries. Your code depends on building those libraries, right? That looks right. Sorry. The simplest Rust programs like the one we have written so far don't have any dependencies. So we had built Hello World project with Cargo. It would only use a part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies. And if you start a project using Cargo, that looks fine. Creating a project, how do you do? Cargo new Hello World or Hello Cargo cd to that, you will see. So we renamed our project to Hello Cargo, and Cargo creates these files in a directory of the same name. Go into Hello Cargo directory and list the files. You'll see that Cargo has generated 2 files in one directory, cargo.toml file and src directory with a main.rs file. It has also initialized a new Git repository along with Git ignore. Git files won't be generated if you run cargo new within an existing Git repository. You can override this behavior by using cargo new uh, system version control system equal to Git. Right, that makes sense. Right, I'm gonna drink my tea while I'm at it. Okay. So I'm probably ouch. That hurts. Sorry. So I'm probably not gonna publish the recording for this because it's something that I'm just doing here. So cargo.toml file in your text editor of your choice should look similar to this: name, version, edition, and then dependencies. Like it's like package.json file. So that this file is in Tom's obvious minimal language format, which is cargo's configuration format. The first line package is a section heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next three lines set the configuration information cargo needs to compile a program. The name, the version, the edition of the rest to use. We'll talk about the edition key in Appendix E. The last line dependencies is the start of a section for you to list any of your project dependencies. In Rust, packages of code are referred to as crates. We won't need any other crates for this project, but we'll in the first project in chapter 2. So we'll use this dependency section then. Alright, so they have done that. Cargo is generated. Okay. Cargo build. Now let's look at what's different when we build and run. Okay. This command creates an executable file in target debug hello cargo or target. Okay, if you're on Windows, rather than in your current directory, you can run the executable with this command. If all goes well, hello world should print to the terminal. Running cargo build for the first time also causes cargo to create a new file at the top level, cargo.lock. So this file keeps track of the exact versions of dependencies in your project. So it's just like I think I've seen with Vite, VITE, for those JavaScript guys. I've seen it there, so that looks right. And the cargo run will run it. Right? Notice that this time we didn't see any output indicating that cargo was compiling hello cargo, because cargo run will only run the compiled binary, right? The files were not changed, that's why. If you had changed them, it will automatically run cargo build for you. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles but does not produce an executable. Okay, that's cool. Okay. Yeah. Target debug directory. Okay. Building for release. When your project is finally ready for release, you can use cargo build hyphen release to compile it with optimizations. This command will create an executable in target release instead of target debug. That makes sense. The optimizations make your Rust code run faster, but turning them on lengthens the time it takes for a program to compile. This is why there are two different profiles, one for development and the other one you want to rebuild quickly and often, and another for another for rebuilding the final program you'll give to a user. That won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code's running time, be sure to run cargo build hyphen release and benchmark with executable in target release. Cargo is convention. With simple projects, cargo does not provide a lot of value over just using Rust C, but will provide its worth as your programs become more intricate. With complex projects composed of multiple crates, it's much easier to let cargo coordinate the build. Makes sense. Alright, so let's go programming a guessing game. I would prefer not doing it now. So the whole point of me trying to learn thing is to just make sure that I'm aware of what I had studied before. So I'm just gonna look at these things. Use std.io, rand, RNG, number generator. Is it? The RNG trait defines methods that random generates random number generators implement, and this trait must be in scope for us to use these methods. Yeah. Alright, so we're not gonna go to the game, we're just gonna go to the programming language. This all is cool to me. Is this an error? First assignment to X, consider making this binding mutable, mute X. The value of X is, because you're doing it here, right? That I was kind of surprised. Why do you raise an error when someone is doing let X equal to 5? That makes sense. Like immutable variables, constants are values that are bound to a name and are not allowed to change, but there are a few differences between constants and variables. First, you're not allowed to use mute with constants. Constants are just immutable by default, they're always immutable. You declare constants using the const keyword instead of let keyword, and the type of the values must be annotated. We're about to cover types and annotations in the next section. Constants can be declared in any scope, including the global scope, which makes them useful for values that many parts of code need to know about. The last difference is that constants may be set only to a constant expression or result of value that could only be computed at runtime. Okay, right. So this is fine. Okay, yeah. Mm-hmm. That's okay. Constants are valid for the entire time in the program runs within the scope they were declared in. Yeah, of course. All right. My mother made tea for me. That's very kind of her. What is shadowing? Is yeah, I forgot. You can declare new variable with the same name as previous variable. Okay. Rustaceans say that the first variable is okay shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any uses of the variable name to itself until either it itself is shadowed or the scope ends. We can shadow a variable by using the same variable's name and repeatedly repeating the use of the let keyword as follows. Interesting. So this program first binds x to a value of 5, then it creates a new variable x by repeating let x equal to, taking the original value and adding 1 so that x is then 6. Okay, so it's over here. Then another scope they have, right, using the curly brackets. I think I'll call it anonymous namespace probably. Shadowing is different from marking variable as mute because we'll get a compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let, we can perform a few transformations on a value but have the variable be immutable after those transformations have been completed. Right, so suppose you want to you just want to play with spaces again, but you don't want to make it mutable throughout this whole, lifetime of spaces. So what you can do is you can use let keyword again and you can reinitialize it to something else. So that's what they mean here. That is interesting. So if you're also changing the type of spaces, earlier it was a string, now it is an integer. Usize, of course, unsigned size, sure. That's what they have as a type. See, that will not be allowed. That is good. That is cool that you can do it. I mean, yeah. So every value in Rust is of a certain data type, which tells Rust what kind of data is being specified. So it knows how to work with that data. We'll look at two data type subsets, scalar and compound. Keep in mind that Rust is a statically typed language, which means that it must know the types of all variables at compile time. The compiler can usually infer what type we want to use based on the value and how we use it. In cases when types are possible, such as when we converted a string to a numeric type using parse, 42.parse.expect not a number, let guess equal to this. If you don't add the U32 type annotation above, Rust will display the following error, which means the compiler needs more information from us to know which type we want to use. Consider giving guess a type. Okay. So sometimes when it's ambiguous, sometimes when they are not sure what type to give, they suggest that please give us a type that you want. A scalar type represents a single value. Let's just force primary scalar types: integers, floating point, numbers, booleans, and characters. You may recognize these from other programming languages. Yeah, makes sense. Integer type we have i8, i16, i32, i64. By default it is i32 if you don't pass, right? And then you have I size and U size. Now that is interesting. Each sign variant can store numbers from minus to power n minus 1 to the power of n minus 1 inclusive, when is the number of bits that variant uses. So i8 can store number of, okay, so 2 minus 2 power 7, so minus 128 to 127 inclusive, right? So that makes sense. All right, so additionally the U size and I size bytes types depend on the architecture of the computer your program is running on, which is noted in the table as arch or arc. 64 bits if you're on a 64-bit architecture and 32 bits if you're on a 32-bit architecture. Okay, that makes sense, right? That is cool, right? I mean, so it automatically detects what kind of architecture you're on and then takes the type accordingly. You can write integral integer literals in any of the forms shown in table 3.2. So that the number literals that can be multiple numeric types allow a type suffix such as 57U8 to designate a type. Number literals can also use underscore as a visual separator to make the number easier to read, such as 1 underscore 000. Where's table 3.2 by the way? Yeah, there you go. 98 underscore 222. What does it mean? To make sure the number is easier to read. Oh, interesting. Yeah, I forgot about it. Right. Always good to come back. Oh, yeah, so that is easier to read. So let's say if I'm saying that probably what is the salary of L5 at Meta, it will have multiple underscores, I guess. Not too much though. So how do you know which type of integer to use? If you're unsure, Rust defaults are generally a good place to start. Integer types default to I32. Yeah. Let's say you have a variable of type U8 that can hold values between 0 and 255. If you try to change the variable to a value outside of that range, it should raise an error, right? Because as far as I know, Python does it for you, that it automatically um, changes the type to something else. Integer overflow will occur, which is good. When you're compiling in debug mode, Rust includes check for integer overflow that causes a program to panic at runtime if this behavior occurs. Rust uses the term panicking when a program exists with an error. Yeah, we'll read about it. When you're compiling in release mode with the release flag, Rust does not include checks for integer overflow that causes panics. Instead, if overflow occurs, Rust performs two's complement wrapping. In short, values greater than the maximum value that the type can hold wrap around to the minimum of the values that type can hold. Okay, I see. So it's kind of a circular thing. After 255, you start again with 0, 1, 2, 3 and all. Right, interesting. So what they say is the program will not panic, but the variable will have a value that probably is not what you're expecting it to have. Relying on integer overflows wrapping behavior is considered an error. To explicitly handle the possibility of overflow, you can use these families of methods provided by the standard library for primitive numeric types. Wrap in all modes with the wrapping underscore star methods such as wrapping add. Return the none value if there is overflow with the checked star methods. Return the value in a boolean indicating whether there was an overflow with the overflowing underscore star methods. Okay. Saturate at the values minimum maximum value. Okay. So we'll look at these later on, such as wrapping underscore add. Floating point types F32, F64. That makes sense. 32-bit, 64-bit. Yeah, makes sense. I think in Python it is can I do that? How do I check? Hmm. I think it was PyTorch that I remember. How do I check? Uh, like all I'm trying to do is I'm just trying to check what's the default type in Python. Right? It just says float. So I think they mean float 64. Those are numpy, right? All of that, right? So what if I do f equal to float 32? There's nothing like float 32, right? It's just this. It used to be numpy, that's why I was doing. Okay, we'll come back to it later on. So this is okay. So they have time annotations here. F64 is double precision. Yeah, numeric operations. That is cool. The Boolean type. This is float. Remainder. The Boolean type. True or false. With T and F is small. Booleans are 1 byte in size. Okay. The main way to use Boolean values is through conditionals. Okay. The character type, primitive alphabetical type. Here's some example of declaring char values. That is nice. The square byte is for 4 bytes in size and represents a Unicode scalar value, which means it can represent a lot more than just a ASCII. Accented letters, Chinese, Japanese encoding characters, emoji, and 0-bit spaces are all valid char values in Rust. Unicode scalar values range from U plus 4 times 0 to U plus D7FF inclusive. However, a character is not really a concept in Unicode, so your human intuition for what a character is may not match up with what a char in Rust. We'll discuss this topic in detail. Okay, so we have tuples. Compound types can group multiple values into one type. Rust has two primitive compound types, tuples and arrays. A tuple is a general way of grouping together a number of values with a variety of types into one compound type. Tuples have fixed length. Once declared, they cannot grow or shrink in size. Okay. Right. So you can take variety of types in a tuple. We create a tuple by writing a comma separated list of values inside parentheses. Each position in the tuple has a type, and the types of the different values in the tuple don't have to be the same. We've added optional type annotations in this example just to make sure that people understand it better. Although these are like inferable, that means the compiler can infer it. So that's not an issue. To get individual, you can unwrap them using x comma y comma z equal to tup. This program first creates a tuple and binds it to variable tup. We're gonna call it tup. It then uses a pattern with let to take tup and return it into three separate values x, y, and z. This is called destructuring. Sorry, because it breaks a single tuple into three parts. That makes sense. Let 500 equal to x dot 0, x dot 1. That's how you access them. The tuple without any values has a special name unit. This value and its corresponding type are both written and represent an empty value or an empty return type. Expressions implicitly return the unit value if they don't return any other value. The array type, another way to have a collection of multiple values is with an array. Unlike a tuple, every element of an array must have the same type. Okay, unlike arrays in some other languages, arrays in Rust must have a fixed length. So both tuple and arrays must have a fixed length. We write the values in an array as a comma separated list squared inside square brackets. Arrays are useful when you want your data allocated on the stack rather than the heap, or when you want to ensure you always have a fixed number of elements. An array is not as flexible as the vector type, though. A vector is a similar collection type provided by the standard library that is allowed to grow or shrink in size. If you are unsure whether to use an array or vector, chances are that you should use a vector, because it provides more options to you. So why not use that only? However, arrays are more useful when you know the number of elements will not need to change. For example, if you're using the names of the month in a program, you know that until tomorrow there are only 12 months, so that's okay. You write an arrays type using square brackets with the type of each element, a semicolon, and then the number of elements in the array, like so. Yeah, ideally, like you would assume that there will be a comma, but there is a semicolon, so that is something to remember. Like, of course, not a comma. Sorry. Yeah, I mean, comma will just say that the second element's type is 5. That does not make sense, right? Here, I32 is the type of each element. After the semicolon, the number of 5 indicates the number of elements in that array, right? I mean, the size of the array. Both are the same, I guess. The array named A will contain 5 elements that will all be set to value 3 initially. Or you can do this as well. So if you want to just initialize the array of size 5 with value 3, that is the same. Okay. Accessing elements is as straightforward as it can be. Invalid. Okay. Yeah. Let A equal to 1 to please index an array index. Let mute index equal to string new. IO stood in read line mute index. You're passing the reference here so that it stores it here. Expect fail to read line. Usize equal to index.trim.parse.expect. Index entered was not a number. The code compiles successfully. If you run this code cargo run and enter 0, 1, 2, 3, 4, the program will print out the corresponding value at the index. If you instead enter a program past the end of the array, such as 10, you'll see output like this. Thread main panicked at index out of bounds. The length is 5, but index is 10. src main.ls 19th line. The program resulted in runtime error at the point of using an invalid value in the index operation. The program exited. Okay. When you attempt to access an element using indexing, Rust will check that the index you have specified is less than. Yeah, that makes sense. So this is an example of Rust memory safety principles in action. In many low-level languages, this kind of check is not done. Yeah, I mean, sometimes you get some segmentation fault, right, in C++. So, okay, IO stood in read line mute index. You save it to the index, which is kind of a string right now. Convert it into usize using index.trim. Any white spaces, right? And dot parse. By default, it will pass it into. How does it work? Let's parse. Yeah, there you go. So passes the string slice into another type, right? And it returns a result, right? So that's why you need to have either a check for .expect. Because parse is so general, it can cause problems with type inference. As such, parse is one of the few types you'll see the syntax affectionately known as turbofish. This helps the inference algorithm understand specifically which type you're trying to pass into. Parse can pass into any type that implements a from str trait. Okay. Will return error if it's not possible to pass a string slice into desired type. So so this is how they're doing it. Dot unwrap. So you already have the desired type as U32. That is possible. So you can also do this. So you can avoid annotating 4 here with U32 and you can do this here. Turbofish. And then you do OK of 4 because yeah, that's gonna be an OK object. Failing to pass is error. Yeah, what I want to see is first of all what is result here. So result is a type that represents either success or failure. Contains the success value, contains the error value. Impl t comma e, result t comma e, pub const is okay. Okay, so we can do x dot is okay. True. Okay of -3. So you're creating a variant of -3. It's saying that this is okay. Nightly only experimental API is error end. Okay, converts to option T. Converts self into option T, consuming self and disregarding any the error if any. Okay. Okay, dot okay will convert into option T. So you can check. Alright. So that's gonna convert into none if there's an error. That is nice. We'll have to see closures, to be honest, properly. We're gonna use them a lot in our code editor. Yeah, I want to see. Okay. So you can also return if something is expecting a result as an output, you can just do okay in brackets and there can be nothing. That is cool. Okay. Alright, so let's go ahead. Okay, so this is good. We have done now functions. I think I know what's happening. I know you can the last statement over here that can be written as well. Yeah, that is okay. Return type is like this, arguments are like this. Comments are also okay. Control flow if I know. So I think if expressions start, right, I think they are different in a way that you can store the output from if um, to your variable as well. Yeah, using if in a less statement. Because if is an expression, we can use it on the right side of a statement to assign the outcome to a variable, right? That makes sense. Because here you see that 5 is the last in the scope and it will be returned. Basically, it doesn't have a semicolon here. So number is equal to 5 if the condition is true, else it is 6. So I've seen it being used a lot of times. Repeating code with loop, right? Loop is going to be infinite times, right? Returning values from loops. Let result equal to loop. So loop is also an expression. Break with counter into 2. Yeah. Makes sense. So Loop labels to disseminate between multiple loops. If you have loops within loops, break and continue apply to the innermost loop at that point. You can optionally specify a loop label on a loop that we can use with break or continue to specify those keywords apply to the label loop instead of the innermost loop. That is interesting. All right, guys, you gotta like we have. Yeah, hi Majoris, thank you so much for joining. I got to hear about that. Technoblade, right? Rest in peace, yeah, rest in peace. I saw his last video. It was emotional, to be honest. It wasn't expected. I mean, probably he knew it coming. Yeah, he was like motivation for 3 years. Majoris says, yeah, that is true. That is really sad. Actually, he even he even left a lot of positive vibes, and he even left a lot of motivation for all people out there through his last video. I saw his last video. That was that was heart touching. So yeah. So the outer loop has the label counting up. It will count up from 0 to 2. Okay, is it? That is interesting. You can do that. You can do this thing counting up, and you can, so basically you have labeled this loop with counting up, and this counting up is changing. Is it counting up, break, counting up? No, right? So break, if count equal to 2, you break this loop. Okay, you break out of this loop. So yeah. Um, that is great. Conditional loops with while. A program will often need to evaluate a condition within a loop. While the condition is true, when the condition ceases to be true, the program calls break. Stopping the loop, it's possible to implement behavior like this using a combination of loop, if else. Yeah, that makes sense. Man trying to be funny this. Gates, yeah. Yeah. I mean, yeah, it was I got really emotional at one point of time watching his voice um when he just said those words. The way he pointed out the prank he was caught into by his cousin brother, and a lot of people made fun of it, right? So the way he remembered those moments, it was amazing, right? Just just totally shows how good he was and who he is, right? He's still in our memories, and his, like, I hope just people keep him in their mind, and keep his legacy alive. That's all I can say. All right, so we have this for number in 1 to 4, right? So you can do that as well. It's gonna be by the way, I'm just curious, it's gonna be exclusive of 4, right? Right, 1 2 3, and you're doing reverse, right? 3 to 1, yeah, of course, lift off. All right, so this is done. Understanding ownership, yeah, that is one of the biggest thing. So ownership is a set of rules that governs how the Rust program manages memory. All programs have to manage the way they use a computer's memory while running. Yeah, some use garbage collector, right? Because ownership is a new concept for many programmers. It does take some time to get used to it. The stack and heap, they talk about it here. Many programming languages don't require you to think about the stack and the heap very often, but in systems programming language like Rust, whether values in the stack or the heap affects how the language behaves and why you have to make a certain decision. Parts of ownership will be described in relation to the stack and heap later in this chapter, right? Both the stack and the heap are parts of memory available to your code to use at runtime, but they are structured in different ways. The stack stores values in order to it gets them and removes the values in the opposite order. That is the first stage. Yeah, last and first, we used to call it LIFO. Think of a stack of plates. Yeah, I mean, I get it. Adding or removing plates from the middle or bottom wouldn't work as well. Yeah, adding data is called pushing onto the stack, and removing data is called popping. Yeah, that I know. All data stored on the stack must have a known fixed size. Data with an unknown size at compile time or a size that might change must be stored on the heap instead. All right, right. So they all must have a known fixed size if you're storing it on the stack. If you're not sure what is the size, what is the type is going to be, it's better that it should be stored on a heap. Must be. A size that might change. Yeah, the heap is less organized. When you put data on the heap, you request certain amount of space. The memory allocator finds an empty spot in the heap that is big enough, marks it as being in use, and returns a pointer, which is the address of that location. This process is called allocating on the heap, and sometimes abbreviated as allocating. Pushing values on a stack is not considered allocating. Because the pointer to the heap is a known fixed size, you can store the pointer on the stack, but when you want the actual data, you must follow the pointer. Think of being seated at a restaurant. When you enter, you state the, yeah, that's okay. So that is really interesting, right? Because of course, the pointer that you get from when you have allocated some space in the heap in the memory, right? So what you'll have to do is the pointer will be stored on a stack, because of course that one thing is known, right? The address is known to you. So yeah, that makes sense. Ownership rules. Each value in Rust has an owner. There can only be one owner at a time. When the owner goes out of scope, the value will be dropped, right? So everything has an owner, and if there cannot be multiple owners for a single thing. When the owner goes out of scope, the value will be dropped. So variable scope, for example, S is not valid here. It's not yet declared. Yeah, the scope is now over. S is no longer valid, right? So that makes sense. So that is something about scopes, right? And we need to probably continue doing that. Okay, otherwise there are two important points in time here. When S comes into scope, it is valid. It remains valid until it gets out of the scope. And the string type we have, to illustrate the rules of ownership, we need a data type that is more complex. Yes, makes sense. We'll concentrate on the parts of string that relate to ownership. These aspects by also apply to other complex data types, whether they are provided by the standard library or created by you. Okay. We've already seen string literals, where a string value is hard-coded into our programs. String literals are convenient, but they are not suitable for every situation in which we may want to use text. One reason is that they're immutable, right? Another is that not every string value can be known when we write our code. Yeah, that makes sense, right? For these situations, Rust has a second type, string. This type manages data located on the heap, and as such is able to store an amount of text that is unknown to us at compile time. Okay. By the way, Majorist, if you're still here, I just wanted to ask, do you hear any noise in the background of cars honking? I just want to make sure that my mic is good, and I've set my like if I should improve anything here, just let me know. If you're still here, I don't know if you're still here, so that's okay if you're not here. All right, so this type manages data located on the heap, as such is able to store an amount of text that is unknown to us at compile time. You can create a string from a string literal using the from function, like so. String from hello. Let double colon operator allows us to namespace. Yeah, that's okay. That is all good. Push string appends a literal to a string. This will print hello world, right? That makes sense. So what's the difference here? Why can string be mutated but literals cannot? The difference is how these two types deal with memory. So you were able to do string from hello. So that was a literal, right? String literal, and you converted it into a string type, right? And you could do push str, and that worked. So what's the difference? Memory allocation. With the string type, in order to support a mutable growable piece of text, we need to allocate an amount of memory on the heap unknown at compile time to hold the contents. This means the memory must be requested from the memory allocator at runtime. We need a way of returning this memory to the allocator when we are done with our string, right? So string literals are fast and efficient, but these properties only come with string literals immutability, right? Because, right, that makes sense. The first part is done by us when we call string from. Its implementation requires the memory it needs. This is pretty much universal in programming languages. However, the second part is different. In languages with a garbage collector, the GC keeps track of it and cleans up memory that is not being used anymore, and we don't need to think about it. In most languages without a GC, it's our responsibility to identify when memory is no longer being used and call code to explicitly free it, just as we did to request it. Doing this correctly has historically been a difficult programming problem. If we forget, we'll waste memory. If we do it early, we'll have an invalid variable. If we do it twice, that's a bug too. We need to pair exactly one allocate with exactly one free. That makes sense, right? So suppose if you're allocating once and you're freeing it twice, you're trying to free it twice. That does not make sense. So Rust takes a different path. The memory is automatically returned once the variable that owns it goes out of scope. So there is a natural point at which we can return the memory our string needs to the allocator. When s goes out of scope, when a variable goes out of scope, Rust calls a special function for us. The function is called drop, and it's where the author of string can put the code to return the memory. Rust calls drop automatically at the closing curly bracket. Okay, so whenever that is s is gone out of scope, whenever that s is out of scope, you can just call the drop function. That is what it has been done by the author of string, right? In C++, the pattern of deallocating resources at the end of item's lifetime is called RAI, resource acquisition is initialization. The drop function in Rust will be familiar to you if you have used RAI patterns. This pattern has a profound impact on the way Rust code is returned. It may seem simple right now, but the behavior of the code can be unexpected is in more complicated situations when we want to have multiple variables use the data we have allocated on the heap. Right, so I think here what has happened is the ownership of X has been transferred to Y. Is it? Oh, okay, so that's not the case. I was wrong. But what happens here? A pointer to the memory that holds a context of the string, a length and a capacity. Right, this group of data is stored on the stack. On the right is a memory on the heap that, the length is how much memory in bytes the contents of the string is currently using. The capacity is the total amount of memory in bytes that the string has received from the allocator. The difference between length and capacity matters, but not in this context. So for now, it's fine to ignore the capacity. I see. Right. So the data is not copied, only this table is copied because anyways the pointer is pointing to the same place. The representation does not look like figure 4.3, which is what memory would like. If Rust instead copied the heap data as well. If that happens, that will be very expensive. Earlier we said that when a variable goes out of scope, Rust automatically calls the drop function, cleans up the heap memory for that variable. But figure 4.2 shows that both data pointers belonging to the same location. That is a problem. When S2 and S1 go out of scope, they will both try to free the same memory. This is known as double free error and is one of the memory safety bugs we mentioned previously. Freeing memory twice can lead to a memory corruption, which can potentially lead to security vulnerabilities. To ensure memory safety, after the line let S2 equal to S1, Rust considers S1 is no longer valid. Therefore, Rust does not need to free anything when S1 goes out of scope. Interesting. So now the ownership of S1, everything has been transferred to S2. Is that it? If you've heard the term shallow copy and deep copy while working with other languages, the concept of copying the pointer length and capacity without copying the data probably sounds like making a shallow copy. But because Rust also invalidates the first variable instead of calling it a shallow copy, it's also called a move. In this example, we would say that S1 was moved into S2. That makes sense. So this S1 does not exist anymore. With only S2 valid, when it goes out of scope, it alone will free the memory and we are done. In addition, there is a design choice that's implemented by this. Rust will never automatically create deep copies of your data. Therefore, any automatic copying can be assumed to be inexpensive in terms of runtime performance. So that's how they take care of performance. They don't do deep copy unless until you do it yourself. Base variables and data interact. If we do want to deeply copy the heap data of the string, not just the stack data, we can use a common method called clone. Right, that makes sense. This works just fine, explicitly produces the behavior shown in this, where the heap data does get copied. When you see a call to clone, you know that some arbitrary code is being executed and that code may be expensive. It's a visual indicator that something different is going on. Stack only data, copy. Oops. There's another wrinkle we haven't talked about yet, the code using integers, part of which was shown, okay. But this code seems to contradict, okay. Because X is still valid, right? That's what I was thinking before. This reason is that types such as integers that have known size at compile time are stored entirely on the X, so copies of the actual values are quick to make. That means there is no reason we want to prevent X from being valid after we create the variable Y. So calling clone wouldn't do anything different from the usual shallow copying, and we can leave it out. Just as a special mention called the copy trait that we want, that we can place on types that are stored on the stack as integers are, if a type implements a copy trait, variables that use it do not move but rather are trivially copied, making them still valid. Okay. So if there's a type that implements this copy trait, right? And when you do let y equal to x, for example, then it will do a deep copy, is it? Right? Rust will not let us annotate a type with copy if the type or any of its parts has implemented the drop trait. If the type needs something special to happen when the value goes out of scope and we add the uh, copy annotation to that type, we'll get a compile time error. To learn more about how to add copy annotation to your type to implement, see derivable types over here. Derivable traits, sorry. We can go back to appendix later on when we need it. Ownership and functions. The mechanism passing value to a function are similar to those when assigning a value to a variable. Passing a variable to a function will move or copy just as assignment does. Okay, cool. S values moves to the function, so it's no longer valid here, right? X comes into scope, X could move, but I30 is copy too. Yeah, makes sense. Got it, sir. If you try to use S after the call to takes ownership, Rust would throw a compile time error. Return values in scope. Returning values can also transfer ownership. Listing 4.4 shows an example of function that returns some value with similar annotations as those in listing 4.3. Okay, takes and gives back S2 and it's going to give us back the same string that was made here. Now ideally that would have raised an error because some string is only in this scope. Some string is returned and moves out of the calling function. So this is, it has moved out of here and it has moved into this. The ownership of variable follows the same pattern every time. Assigning a value to another variable moves it. When a variable that includes data on the heap goes out of scope, the value will be cleaned up by drop unless ownership of the data has been moved to another variable. While it works, taking ownership and then returning ownership with every function is a bit tedious. What if you want to let a function use a value but not take it as reference, right? Does let us return multiple values using a tuple. So we have s2 comma length being written from calculate length, s comma length. Yeah, references. There you go. So they've talked about references here. The issue with the tuple code in listing 4.5 is that we have to return a type string to the calling function, right? Instead, we can provide a reference to a string value. A reference is like a pointer in that it's an address we can follow to access the data stored to that at that address. That data is owned by some other variable. Unlike a pointer, a reference is guaranteed to point to a valid value of particular type for the life of that reference. Here's how you would define and use a calculate length. You just pass the reference of s1 here. That will be the address and you take that as a reference here. That makes sense, right? So this is what we are doing here. This is all cool. First, notice that all tuple code in the variable declaration and the function return type is gone. Second, note that we pass ampersand s1 into calculate length, and its definition we take ampersand string rather than string. Right. Note the opposite of referencing by using ampersand is dereferencing, which is accomplished by dereferencing operator. Right. That makes sense, sir. The scope of the in which this variable s is valid is the same as any function parameter scope. Yeah. So it's not dropped. We call the action of creating a reference borrowing as in real life. Okay. So when you create a reference, it's called borrowing. Okay. As in real life, if a person owns something, you can borrow it from them. When you're done, you have to give it back. You don't own it. So what happens if we try to modify something we are borrowing? Okay. You cannot do that. So you need to convert into a mutable reference. Makes sense. Makes sense. You can just do ampersand mute. And you need to do both sides. That is great. I love it. Mutable references have one big restriction. If you have a mutable reference to a value, you can have no other references to that value. So here R1 and R2 are both trying to attempt to create a mutable reference to S, and they are not allowed to do that. Cannot borrow S is mutable more than once at a time. So it's just, if you try to think of it, you cannot borrow a same thing from a same person twice. simultaneously. That is just not possible, right? He can have that thing, he can give it to one person for just a while. It has to take it back and then give it again. Yeah, that makes sense. The restriction preventing multiple mutable references to the same data at the same time allows for mutation but in a very controlled fashion. It's something that new illustrations struggle with because most languages let you mutate whenever you like. The benefit of having this restriction is that Rust can prevent data races at compile time. A data race is similar. Yeah, I mean, I know about it. Data races cause undefined behavior and can be difficult to diagnose and fix when you're trying to track them. Yeah. So this is fine. This makes sense. Rust enforces a similar rule for combining mutable and immutable references. This code results in an error. So you can do that because it's not mutable. Immutable reference is fine. Immutable borrow occurs here, no problem. Immutable borrow occurs here. When we also cannot have a mutable reference while we have an immutable one to the same value. Okay. Users of an immutable reference don't expect the value to suddenly change out from under them. However, multiple immutable references are allowed because no one who is reading the data has the ability to affect anyone else's reading of the data. Okay. Note that a reference scope starts from where it is introduced and continues to the last time that reference is used. For instance, this code will compile because the last usage of the immutable reference, the println occurs before the immutable reference is introduced. Interesting. Makes sense. Hmm. The ability of the compiler to tell that a reference is no longer being used at a point before the end of the scope is called non-lexical lifetimes. And you can read more about it in the edition guide. Even though the borrowing errors may be frustrating at times, remember that's a Rust compiler pointing out a potential bug early. Makes sense. Dangling references, yeah. In languages with pointers, it's easy to erroneously create a dangling pointer, a pointer that references a location memory that may have been given to someone else by freezing some memory while preserving a pointer to that memory. In just by contrast, the compiler guarantees that the references will never be dangling references. If you have a reference to some data, the compiler will ensure that the data will not go out of scope before the reference to that data does. Hmm. So here they have tried to create a dangling reference. They have created a string in this dangle function and they're returning the only the address here. They are not returning the whole string, so it will not be copied, right? The scope will not change. So this will expected name lifetime parameter. This function's return type contains a borrowed value, but there is no value for it to be borrowed from. Consider using the static function. This error message refers to a feature we have not covered yet, lifetimes. Okay, these functions, let's take a closer look at exactly what's happening at each dangle code. Dangle returns a reference to a string. Yes. We return a reference to the string s. Here s goes out of scope and s dot s memory goes away. Denture. Yeah. So because s is created inside dangle, when the code of dangle is finished, s will be deallocated, but we try to return a reference to it. This means this reference would be pointing to an invalid string. That's no good. Rust won't let us do this. So now this is okay, of course. Alright, so this is done. References and borrowing is done. The slice type was interesting. So we have, I think, till here or here. We have to cover till 10th, and then probably tomorrow we can try to complete other chapters. Alright, so the slice type lets you reference a contiguous sequence of elements in a collection rather than the whole collection. A slice is a kind of reference, so it does not have ownership. Slices let you reference to a contiguous sequence of elements in a collection rather than the whole collection. Here's a small programming problem. Write a function that takes a string of words separated by spaces and returns the first word it finds in that string. Right. But what should we return? We don't really have a way to talk about part of a string. So here they're converting into bytes first. then they're iterating through it for I comma item. If item equal to b, sorry, if item is equal to space, return I. Right, so that's going to return I. S is going to return. All right. Because we need to go through the string element by element and check whether the value is space, we'll convert our string to an array of bytes using the sbytes method. Next, we create an iterator over the array of bytes using the iter method. We'll discuss iterators later on. For now, know that iter is a method that returns each value in a collection, and that enumerate wraps the result of iter and returns each element as part of a tuple instead. The first, yeah, that is index, and the second value is a reference to the element. It's a reference to the element, right? Because enumerate method returns a tuple, we can use patterns to destructure that tuple. Okay, that is done. Inside the for loop, we search for the byte that represents a space by using the byte literal syntax. If we find a space, we return the position. We now have a way to find out the index of the end of the first word in a string, but there's a problem. While we are returning a usage on its own, but it's only a meaningful number in the context of the string. In other words, because it's a separate value from the string, there's no guarantee that it will still be valid in the future. Right, so what if S has changed to something else? So after this, words will still contain 5, which is not true. Because word is not connected to the state of S at all, word still contain the value 5. We could use that value 5 with the variable S to try to extract the first word out, but this would be a bug. Okay, yeah. Managing these indices is even more brittle if you write a second word function. Its signature would have to look like this. Yeah. So Rust has a solution, string slices. A string slice is a reference to a part of string, and it looks like this. So you have string from hello world, right? And what you're doing is let hello equal to 0 to 5 exclusive, right? Hello is a reference to a portion of the string specified here. We create slices using a range within brackets by specifying starting index to ending index. The starting index is the first position in the slice, and ending index is one more than the last position in the slice. Internally, the slice data structure stores the starting index and the length of the slice, which corresponds to ending index minus starting index. So in that case, let world equal to world would be a slice. It contains a pointer to the type at index to the byte in index 6 with a length of 5. That makes sense. Yes, sir. So it excludes 5 from there and 11 from there. With Rust dot dot range syntax, if you want to start at index 0, you can drop the value before the two periods. In other words, these are equal. So 0 to 2 and dot dot 2. So you can drop 0. By the same token, if your slice includes the last byte of the string, you can drop the, yeah, that makes sense, sir. That is okay. With all this information in mind, let's rewrite first word to return a slice. This type that signifies string slice is written as %str. Bytes, okay. Return. So instead of returning I, you're returning a string slice. %s 0 to I. We get the index for the end of the word in the same way as we did in listing 4 to 7 by looking for the first occurrence of space. When we find a space, we return a string slice using the start of the string at the end and the index of the space as the starting and ending slices. That makes sense. Now when we call first word, we get back a single value that is tied to the underlying data. The value is made up of reference to the starting point of the slice and the number of elements in the slice. We now have straightforward API that's much harder to mess up because our compiler will ensure that reference to the string remain valid. Yes. So this will error out. Immutable borrow occurs here. Mutable borrow occurs here. So clear needs to truncate the string. It needs to get a mutable reference. The println after the call to clear uses reference in word, so the immutable reference must still be active at that point. Rust disallows the immutable reference in clear and the immutable reference in word from existing at the same time. Right. Recall that we talked about this. So string letters are slices. That's what it says. It's a slice pointing to that specific point of the binary. That is also why string letters are immutable. Ampersand str is an immutable reference. Slices are parameters. Knowing that you can take slices of letters and string values leads up to one more improvement on first one, and that's signature. A more experienced statistician would write the signature shown in listing 49 instead, because it allows us to use the same function on both string and str values. Listing 49, yeah. If we have a string slice, we can pass it directly. If we have a string, we can pass a string slice of the string on a reference or a reference to a string. This flexibility takes advantage of dereference coefficients, a feature that we'll cover in later on, okay, in chapter 15. Define a function to take a string slice instead of reference to a string makes our API more general and useful without losing any functionality. Hmm. Right. So this is also allowed. That is good. Okay. So one thing I just want to check. Um, Let me quickly do this thing. What I want to do is I want to call a func with push. Right, so this is what I want to check. I think this will, what happened? Yeah, there you go, right? So it expected a struct string found str. So this is not allowed, right? By the way, we can probably do this here. What about this? Does it get rid of the first error? Yeah. And if I do, so this should also fail. There you go. If I do this, this is, so by the way, I think we should do Rust analyzer as well. I'm excited to use Rust analyzer here. Let's see. I guess it will raise an error. Come on, Rust. Tell me what you got. Hmm. Args the path, right? LSIF. Okay. SSR, a structure search, replace rule. Diagnostics, directory with cargo.uml. Makes sense. Hmm. What I would like to do is I will also try to get the Rust analyzer set up. I also want tmux. Much better. How do I resize? Mm, I don't know what I did. I can detach. I can do new session. How do I do new session? T tmux new session and tmux resize. Control B is it? Control B. So I can move between both of them. I have the time written here. That is great. I can enter the full screen mode, which is good. Hmm. So they have some bindings here, adjusting tmux size. Yeah, I think I'll do that as well. Let's see. How do I resize, sir? Okay, that is also good. Yeah, I'll fix it. Hmm. Yeah, I will do this. Hmm. This is okay. Oh, so I can do this using mouse as well. This is cool. What about Rust C main.rs? Wait, sorry, Rust. Okay, let's do this main. Let's get an error here just to make sure. Cargo made a no depth format version. Could not find cargo.ml. Yeah, sure. I'll fix it, sir. Don't worry. You want a new project? There you go. What happened? Let's keep doing this. Right now, I just have this question. Can I scroll up? Yes, I can. What about Vim? Um, okay. So I just want to see whether I can scroll up or not. I can scroll up here. This is all good. Um, Can I scroll up? Yeah, this is all good. Cool. Cool. I think I'm happy with it. Cool. Let's go back to our book. We have been studying for around 1 hour 10 minutes, guys. That is great. With I think max one unique viewer. So yeah, I would also do Rust analyzer setup now. I think I'm clear about slices now. So you can also pass slices to part of an array. Alright, so we have done till 4th chapter today. Using structs, I would like to do this. Defining and instantiating structs and all of that. But I want to take a break. And I want to go back. What is it? Oh no, I don't need it. Just analyzer setup NeoVIM. Yeah, I think. Wait, what happened? Why is this like this? Why is this? All right, all right. I'm gonna skip. What is this? Hmm. Why does it? Now this is okay. Cool. So if I go to sample now, and if I go to main.rs, and if I do rest analyzer received at LSP rest analyzer received n with no something like that, right? Yeah, what is so wrong with this? Yeah, it is broken. So they fixed it here. So I think what we should do is probably go to Rust Analyzer and try to install it here. 5 days ago was the latest release. How can I build it? Alright, I think it will come, right? Latest Git version. It's latest updated on what, 2020? Seriously? This is still active. Hmm. Hmm. So what I would like is I will probably like to make a mistake. Such missing. Oh, sorry. So at least it's working, which is good. So how do I set up Rust Analyzer NeoVIM setup? Yeah, let's try to look at how other people did it.
NeoVIM 0.5 Plus and Rust 2021 Plus. So what we do is make sure we're sorting both all and it takes the server. Now when it's done, take a look at is good. Okay, I'll go to Delta and source edits.
What they have is delta.
And we'll open up source edits. And we can take a look at what we get with some of the things we're going to show you. One of them, we can see here that the tree sitter, we can see here that so GSBuff toggle with Rust Analyzer, you get inlay hints. You can see some of the different options we get here from the Rust NeoVIM tools plugin. And you can see that we have our runnables, which are different tests.
Hmm. But I don't have these options, right? Maybe I'm just not. Right, right. Let's do that. Rust tools. And plugins equal to here. Let's make sure we add a comment for LSP. And what was the name, sir? What was your name? Simrat 39 slash rust-tools.nvim. I think I already have nvm lsp config and pop-up may be sure. I'll keep it nvim lua popup.nvim. Telescope should be there already. nvim lua plenary. I'm not sure, so I will keep it. Or maybe I'll keep all of them. Plenary.nvim and nvim telescope slash telescope dot nvim. Is that it? Okay. Optional dependencies, and I can just copy it here and keep it here. All right, so let's update it. Yeah, plugin telescope.vim is used twice, so we might want to get rid of it. Anyways, let's go to src main.rs now. And now let's go to Rust emit asm. This is cool. Just expand unrecognized pattern pretty. Why?
Runnables, which are different tests. Takes a little bit of time. And what you're seeing, but you can see the test pads. And what you're seeing there is trees that are highlighting instances with
Hmm. Okay, let's try to do this. Vim config and vim the same thing. Let's come here, tree sitter, leaf factor. And let's go to here nvim tree sitter slash nvim tree sitter leaf factor. Backward sync. Sync. There you go. What? Is that not the way? I'm not sure.
annotated plus lines. Go here, we get tokenized, we get a nice definition here, and this is actually the declaration. here you see the string selects that tokenize, we get a nice definition.
But sir, how do you get the, what are the shortcuts? My dot files git delta. I would like to see Rust tools. Everything is installed. Hmm, that is a lot. Hmm, yeah, I think I like it, right? Trace data is there, completion is here. Hmm, okay, let's go step by step. This is what they ask us to add. So let's do it here. Cool. This is done. Now, if I had to do, yeah, Shimali, CD, streams, sample, git show. But I want to change something. How about I go to Bismuth instead? I think it's a better. Let's try to do Vim engine.cpp, right? And let's do something here. Sample edit, right? And do git show. Nice. Wait, I did not add it. Is it? Ah, is it? It's showing commit by commit. That is interesting. Improve git blame display. Is it? Oops, sorry. If I do engine.cpp, if I do git blame, git blame, is there nothing like, yeah, this is okay. Hmm. Okay. All right, so we are just delta show syntax themes dark. That is really nice. Please see the user manual configuration. Like, why does git claim not work? What does it need? It needs the file, right? So if I do git blame src core engine.cpp, that is what it's gonna show me. What I would like to see is NeoVIM. Okay, what does, let's try to explore it. GF, what is GF? Yeah, I will. I'll look at it later probably. Looks more complex than what I want to do right now. Let's just do, there was the video. Oh, I was looking at the, at his config file.
Here, this is actually the declaration. Here you see the string select. Same with deck here. Read all about it. I can. Same with deck here, and you see that I have this option to pick all the. And if I wanted to go here, then I could. And you see the quick fix list gets populated. I say let mute talks, and then we'll just say deck, and you can see that I get some nice information. The hover there.
Do I get this? Uh, I don't know. Let's open any. Let vec. Yeah, I also get that. Which is cool. Can I get the. Okay. Can I also get let vec equal to vec? Let's try to do a mistake. I don't know. I can I apply reformatting. So reformatting works. Um, capital S. So they have this. Okay, this is not bad at all. Rename current symbol is the signature help. LSP code action. Change visibility to pub. So that's what they had as a suggestion. Hover diagnostics. What else do we have? It does not give me anything, everything, right? What I want is rest, rest format, no rest plain. So I can do rest run, right? In order to run this, and if I make an error and I do rest run, I get an error, right? And I can,
The, all the apps work in Telescope. You can see it getting, you need to clone the repo and tools, and you can go through and check that, which you saw before, that we used the runnables, and you'll definitely want tree sitters so that you can get nice highlighting. This is the Rust Up and plugin. It's up to you if you want to use and look at these plugins here. So this one is, I decide if that's something you want to keep. And then here with Rust Analyzer, you'll want to have your capabilities unattach, unattach. You're using Rust Analyzer. You do have some options around here. And you definitely want to use copy. Then some of the stuff that you saw in Tree Sitter would like to insert, and this here sends the diagnostics to the quick fix list. So all this is available in the what's that smell read within the Rust, so that you get the Rust Tree Sitter highlighting and telescope, which current be kind. I'm not using signature with Rust. You'll want Tree Sitter Refactor. That was helpful. Okay.
that was good, but what I'm hmm, right. Okay, it already exists. That is good. Okay, now if I do, I want to see the diff. Okay, I think we get. Color arc always dark. Paging equal to never. Then I want Vimium. What is this? I've heard about it. I don't know. Style word or Tom. Auto prefer double call parenthesis none. Okay, so they have some snippets here. What about alacrity? That is proper, just colors and all. Starship they have. So let's just try to clone this, I guess, and use it. Let's try to use it. I don't know. Just feel like using it. MV, NVIM backup, git clone, NVIM. Should not have done that. What's wrong? Did I not copy the whole? Right, this should work. Let's go to dots, MV public dots. I don't know, Vim NVIM slash everything to this current directory. Oh wait, this is bad. rmrf readme save license mv public dot star. What was I doing? Vim NVIM, right? Star dot. Let's do NVIM packer sync. So what is it expecting? NVIM tree sitter, not query, not found. Module, this is not found. Okay. Yeah, right. So maybe it's just because we are not in the latest release of NeoVIM. Can I do sudo pacman sy NeoVIM? Is a NeoVIM AUR git? NeoVIM git, right? 23rd of April it was latest updated. That means we don't want that. Releases 5 days ago. I think I can keep it to the latest one by going to cd tmp, I guess. Or no, I can actually create documents, projects, installations. Git clone NeoVim. Which version are you on, sir? So he says that he prefers to use the latest branch. Let's see if it really works. Hmm. All right. So we are almost done here. And then we will do probably sudo make install. Yeah, that's it. Alright, so once this is done, what we will try is but I don't want to change the colors that I had. Wait, what happened to NVIM? Ah, so that's why it happened. Shit. Okay, let's still do this. It's okay. Half of it is about, just trying. Lua dev not found. We'll look at it. Hmm. Is there something like Lua dev? No, right? Hmm. I think we should fix it first of all. Style Lua is not installed. Style Lua. What happened? Why is it not showing it? Oh, sorry. Can I go to 76 lines, sir? The language server is either not installed. Yeah, we look at it. WinBar get sign status. Do I have WinBar? WinBar A1. Right, it exists, right? I hope he is looking for this. If not, I'm screwed. Let's see. There are errors, but incomplete type. Bind is not a member of STD. They were just not ready with it, is it? Have they used Joel anywhere? Oh God, they have. They have it everywhere. So this config.lua is also wrong, right? How can I change, rename in all files something terminal. I mean, this should not be terminal, but rename word. It is SED, right? Yeah. Yeah, there you go. SED hyphen I Joel with KR Shimali. Oh no, not this. Slash KR Shimali slash G star. What happened? Oh sorry, S slash couldn't edit after not a regular file. No input files. Why? Okay. Grep hyphen RLI Joel star. Okay, that gives me all the files that have been. X args hyphen I at SED hyphen IS Joel slash KR Shimali G at. Okay, let's try to do grep R Joel now, and grep R KR Shimali should be found. Right, okay. Now I need to replace the local vim lua KR Shimali config.lua users who highlights the column. Yeah, what was the set column? I forgot. This is weird. Vim dev lua language server hyphen I main.lua. Let me do packer sync again. Let's see. That pretty much teaches me that you should never use someone else's config file. Let's go back to our default one. Completion with tab NeoVIM. NVIM CMP, right? Snippy is there. Alt snips is there. vsnip is there. Okay, first of all, let's get rid of NVIM. Let's move NVIM back up again to NVIM. CD NVIM, right? And let's do NVIM plus packer sync again. Yes, please remove everything you want. Thank you so much, sir. Are you working? You are working. Thank you so much for working. Now what I want to do is I want to probably add it somewhere here. Will this work? Expected expression. Okay, please go back. I'll try to edit myself. At least I learned something. So we will add new vim and vim lsp config should also already be there. Then we will add this, and then we will add. Let's probably have this is this. Much better. All right. So we have cmp buffer. Okay. Hash 7th cmp hyphen buffer. Then we have hash 7th cmp path. We have the same guy, cmp path. We have hash 7th cmp cmd line. We have 7th nvim cmp. For vsnip users, Lua snip I'm not going to use. Ulti snips I think I will use. Qang and guy en30192 cmp and ulti snips. Such a cool username. Snippy the decompose. Alright, so we have it here. Now we do set. Now how do I do this? Hmm. Alright, new Vim. Hmm. I think we should just get rid of it. Yeah, I'll probably go for. I'll have to learn NeoVIM for it. I'll probably keep it here, and I will add multi snips. Right, and how do I do this? Right, how should I add? So in okay, in Vim init.lua you can add it here, right? Let g ulti snips expand trigger equal to stab, right? Where is grep let g? How to add let g command to new vim? Hmm. Like for example, vim toggle term.lua. It has this. Hmm. So how do I do it for? Wait, what was that plugin? So I was trying to use. Ulti snips NeoVIM. Hmm. But bro, where do I add it? I think something went wrong. How do I fix it? Yeah, I don't know. I don't know how to write NeoVim. Yeah.
The first is I already have that as intelligent, so it has mutation two. All right, what I want to do is you're gonna want to do, and I think it's pretty sane. The next thing that we'll do is we'll open up just a file with some code in it. All right, and so this is the whole thing is general ones, RF. So now this one being now before we
So can I do Vim configs ulti snips not Vim? Will it work? Python 3 is not there. What? Ulti snips Python 3 provider. Wait, why? Why do you have to do this? Wow. Um, configs ulti snips dot new vim. Right. I think we can do control K and control K. Ulti snips edit split. Okay. One thing I want to do here is I want to set the directory. There's also snippets. Okay, we'll do that. Now, sir, where are the hmm, echo runtime path? What? Okay. Okay, got it. Select G, LT, snippet directories equal to LT snips, comma, plus, let's say rest snippets. Okay, uh, let's call it snippets. Okay, snippets, NeoVIM. Right, so something like, yeah, you can probably get all of these here. cpp.snippets, for example, you can just copy all of them, cpp.snippets, and paste it here. Right now, once this is done, hmm, what happened? Invalid line. Who's Honza, right? Alright, so once this is done, can I do invalid line priority -50 snippets, LT snips? Hmm. So do I have slipmate somewhere? No, right? Okay. What was the error? Hmm. So I think it works now. What are the snippet main, right? So it should show me that these snips. Main tab. Main tab. Yeah, there you go. Right. So now you can do this. Like I can do tab, right, and hit enter. Okay. So let's just do this, that we should get all the. Okay, do we have any samples here? Oh, so the official home is here. Where was I looking at it? I was looking at this only, right? Okay. Can I get Vim snippets? GitHub. Probably this. Snips. I use Python. I use C. I would prefer Python.snippets. Rust snippets. I think that's all I need. So this is C.snippets. So I can definitely add my own. That is undoubtedly the option. What happened? Yes, sir. Please continue. What is up here? Wait, that's it? Sure. So later on we can add our own. Okay. So if I go to documents, project KR Shimali, open source, let's say streams, and if I do right, so we can do this. Let's just fix one more thing and then we are done. Rust analyzer received n with no end. Right, so this has been fixed here. Alright guys, I think I will have to go. So this has been fixed. I will install it here, sudo pacman -r rust analyzer. So I think that will remove it. And what I want to do here is install it using git. Can I do that? Wait, it will install it for me, right? All right, so what is the can I get symbol outline? All right, Rust analyzer get symbol type. NeoVIM. Rust analyzer get type of variable. So if I don't do this, it says it expects one argument. Sure, I did this. No code actions available. So probably we'll have to go to vim config nvim lua user init. Rust. We had Rust analyzer here. We did not have it. Rust analyzer NeoVim. Wait, GitHub toggle byte. NeoVim setup, right? Alright, guys. I think that's it for today. We will do rest of the stuff tomorrow. Okay.